Data mining, unlocking insights from big data. Data mining, a core component of big data science, involves extracting meaningful patterns, knowledge, and insights from vast amounts of data. This process is crucial for transforming raw data into valuable information that can inform decision-making across various industries. As data generation continues to explode, the importance of data mining has grown, making it a key area of focus in both academic research and practical applications. Key techniques in data mining. Association rule learning. This technique identifies relationships between variables in large datasets. A common application is market basket analysis, where retailers analyze purchase patterns to understand which products are frequently bought together. The famous example is discovering that people who buy diapers often buy beer, which can inform store layout and product placement. Classification. Classification algorithms categorize data into predefined classes or groups. This supervised learning technique is widely used in spam detection, sentiment analysis, and medical diagnosis. For instance, a classification model can be trained to differentiate between spam and legitimate emails based on labeled examples. Clustering. Unlike classification, clustering is an unsupervised learning technique that groups data points into clusters based on similarity. It is particularly useful for market segmentation, where businesses can group customers with similar characteristics for targeted marketing efforts. Regression. Regression analysis predicts a continuous outcome variable based on one or more predictor variables. It is essential in forecasting applications, such as predicting sales, stock prices, or environmental changes. Anomaly detection. This technique identifies outliers or unusual patterns in data that do not conform to expected behavior. Anomaly detection is critical in fraud detection, network security, and fault detection in industrial systems. Applications of data mining. Data mining has diverse applications across multiple sectors. Retail. Retailers use data mining for customer relationship management, sales forecasting, and inventory management. By analyzing purchase history and customer preferences, companies can develop personalized marketing strategies and optimize stock levels. Finance. In the financial sector, data mining is employed for credit scoring, risk management, and detecting fraudulent transactions. Financial institutions analyze transaction patterns to identify potentially fraudulent activities in real time. Healthcare. In healthcare, data mining aids in disease prediction, patient diagnosis, and treatment effectiveness analysis. By mining patient records and medical histories, healthcare providers can identify trends and improve patient care. Telecommunications. Telecom companies use data mining to predict customer churn, optimize network performance, and enhance customer service. Understanding usage patterns and customer behavior helps in devising retention strategies. Challenges in data mining. Despite its potential, data mining faces several challenges. Data quality. The accuracy of data mining results heavily depends on the quality of the data. Incomplete, noisy, or inconsistent data can lead to misleading insights. Scalability. Handling large-scale data efficiently is a significant challenge. As datasets grow in size and complexity, developing scalable algorithms and systems becomes imperative. Privacy and security. Mining sensitive data raises privacy concerns. Ensuring data security and complying with regulations like GDPR is crucial to protect individuals' privacy. Conclusion. Data mining is a powerful tool that unlocks hidden patterns and insights from massive datasets, driving innovation and informed decision-making across industries. As data continues to proliferate, the techniques and applications of data mining will evolve, further solidifying its role in the data-driven world. Balancing technical advancements with ethical considerations will be key to harnessing the full potential of data mining.